In 8.4, we're going to continue to use like our tangent, sine, cosine, all those trig functions. We also just have a couple of new terms here. So we have this idea of an angle of elevation and an angle of depression. So basically, both of them, like you kind of have this idea of this horizontal line, and then the angle of elevation is from the horizontal line, like going up. The angle of depression is from the horizontal line going down. So angle of elevation is an angle made from the horizontal line from one object to an object above it, so we're going up. Angle of depression is an angle made from the horizontal from one object to an object below it, so again, we're going down. So if I look right here, angle 1 is an angle of depression from the bird to the balloon. Okay, again, here's the horizontal line and the angle, the object, so the bird is looking at an object below it. So the angle is below the horizontal line. Angle of 2 is elevation. Oops, I spelled that wrong. From balloon to bird. So again, I'm not using the same horizontal line, so I'm using this horizontal line, but it's the person looking at something above it, so it's the angle's above, so it's elevation. Angle 3 is depression from the balloon to the ground. So again, horizontal line, person looking down here in the ground, angles below it. Angle 4 is elevation, I still can't spell that word, from the ground to the balloon. So here, so I'm at the ground looking up to the person. This is the horizontal I'm using, so that's the angle of elevation. Okay, so these ones, like I said, we're still going to be using our SOHCAHTOA stuff. There's just a lot more word problems here. So you sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground and you are 1,000 feet from the base of the cliff. What's the approximate height of the rock climber from the ground? So here's my rock climber. Here am I. So my eye level is, so this distance right here is 6 feet above the ground. Here's the cliff the rock climber's on. I made a 90-degree angle. And it says, I see him at a 32-degree angle of elevation. So there's my horizontal. There's my angle of elevation. My eye level is 6 feet above, and I'm 1,000 feet from the base of the cliff. What's the height of the rock climber from the ground? So I want to figure out this distance right here. Well, if I'm just thinking about, I know that this part's 6, but if I'm just thinking about my triangle, let's just call that x. So this would be here's my angle, this would be my opposite, this would be my adjacent. So I would be using my tangent function. So opposite over the adjacent. So remember, when you're doing these problems, you need to make sure that your calculator is in degree mode. So again, I would go to mode. So I look at that degree right there, so I'm good. So I'm going to go to tangent 32 degrees times the 1,000. So my x is approximately 624.9, but that's not really how high the rock climber is off the ground. I have to take that 624.9 and add 6 to it, so I get 630.9 feet. So the rock climber is 630.9 feet off the ground. Okay, this one. An airplane pilot sights a life raft at a 26-degree angle of depression. So here's my airplane. Here's my raft. And it says it's at a 26-degree angle of depression. So there's my horizontal. So this is my 26-degree angle of depression there. Here's my right angle. The airplane's altitude, so the airplane is 3 kilometers off the ground. If you notice here, this distance right here in this triangle is also 3, okay? And it says, what's the airplane horizontal distance from the raft? So the horizontal distance, I just want to find this distance, or I can think about it as this if I'm looking at this triangle. So again, there's my angle. I have the opposite. I have the adjacent. So the tangent of 26 degrees is equal to the opposite over the adjacent. So this ends up being the x is 3 divided by the tangent of 26. So I get x is approximately 6.2 kilometers. And I don't have to add anything extra to this one because it's not like, you know, I'm looking at it from my eye level or anything like that. That's just where I'm at, okay? All right, let's look at a couple of these to do together. Let's see here. 23 is a weird one. And 30 and 24 is a weird one. So let's look at 23, 24, 30. All right, so my book. Okay. Excuse me. 23. So the world's tallest flagpole is a 282 tall steel pole in Surrey, British Columbia. The shortest shadow cast by the pole during the year is 137 feet long. So here's my shadow. To the nearest degree, what's the angle of elevation of the sun when casting the flagpole's shortest shadow? All right, this one is weird because it says angle of elevation of the sun. So you would think, okay, here's the sun up here, la la la, there's my horizontal. Okay, angle of elevation, I gotta go above. So the sun's probably not up there when it's making its shortest shadow. So the sun is probably just rising from the ground. So the sun is probably down here, just like, you know, appearing during the sunset. And if this was the horizontal, then here would be the angle. So this would be the angle of elevation, okay? So that's how you want to think about this one. What I've done here, though, is I've tried to, like, make this, so this is the 90-degree angle. This is also 282. They share that reflexive side. So this is, these two triangles are congruent. So whatever that angle of elevation is, that's the same angle over here. Sorry, yeah, 282. No, sorry, this is the 282. There's the right angle. This is 137. So these are congruent. So then whatever this angle of elevation is, that's the same angle over there. So they're congruent by side, angle, side. Side, angle, side. I can't talk today. All right, so these angles are congruent. So whatever, you know, this elevation is, that's the same thing over here. So here's the elevation. This is the opposite. Here's the adjacent. So when I find this answer, I'm going to do the tangent of whatever that angle is the opposite over the adjacent. So if I'm trying to find that angle, remember I used the tan inverse function. So tan inverse. So we have 282 divided by 137. So x is equal to 64, 0.1 degree. It does say round it to the nearest degree, so it's just approximately 64 degrees. Okay, so that was number 23. I said I would look at 24 with you. All right, 24. 24 says we have two office buildings that are 51 meters apart. They're not the same height. They're 51 meters apart. The height of the taller building is 207. The angle of depression from the top of the taller building, so remember depression, here would be my horizontal, this would be my angle of depression right here. From the top of the taller to the top of the shorter is 15 degrees. This right here is my right angle. And I want to figure out I want to find the height of the shorter building. So I want to find this height right here. But if I just find this height right here, I could just subtract it from the 207. So if you look right here, I've got a nice, albeit an upside down one, but a nice little right triangle with this is 15 and this is the 51 right here, okay? So this is the opposite, this is the adjacent. So I could say the tangent of 50 degrees is the opposite over the adjacent. So I'm going to just have 51 times the tangent of 15 degrees. So I get x's, I'll keep a couple of decimal places right now. So remember, that's not how tall the building is. That's just that distance right there, the distance between the two. So height of the short building would be 207 minus 13, I'll just say 13.7 then. So I get 193.3, and this was in meters, so meters, okay? So that gives us 24. And then I said I'd look at 30 with you. Okay, for 30, so 30 says that we have an airplane that's at some altitude and it's flying at some horizontal distance toward me at velocity d. I'm like, here I am hanging out right there. Hello. So it's flying towards me at velocity v, and I observe it for some amount of time, and I measure the angle of elevation at the start and the angle of elevation at the end. So like the plane, like, I need another color. Where's that pencil? So the plane like moves after a certain amount of time. So the plane's like over here now. So I have an angle of elevation at the beginning and I have an angle of elevation at the end, wherever it ends up, okay? So in the first scenario, in 30, it's starting off here. I don't know that height there. So I've got the first triangle where I don't know the height. I know the velocity is 5 miles per minute. I know that 1 minute has passed. And I know that my angle of elevation the first time is 45 degrees. but then my angle of elevation is 90 degrees the second time. Well, if it's 90 degrees, basically there's really not a triangle here, because if it's 90 degrees, that means here I am and the airplane is like right above me. So the airplane is now right above me. So now that's that A right there, okay? The distance, but if it went from 45 and now it's right above me, it's traveled for 1 minute. So that horizontal distance that it's traveled has to be 5. So that's the horizontal distance. Then if I want to figure out the altitude, so basically I have, here's a 45-degree angle, opposite and adjacent. So I would be using my tangent function. So the tangent of 45 degrees is the opposite over the adjacent. So I would do tangent 45 times 5, and I end up with 5. So it's a 45, 45, 90 triangle. So, I mean, you wouldn't even have to use tangent. You could just use special right triangles, and knowing that that was going to be isosceles, because I made it so basically what I did is I took this triangle right here and I just flipped it over, okay? So that's that answer. All right, that is that.